Hey everyone, I am going to do a short lesson here on factoring. It was requested by a student, so I wanted to walk through a couple of ideas here with factoring and how I do the factoring. As you can see here, I have labeled, I've got an easy, medium, and a tough factoring problem. They're all done in exactly the same general way. I'll explain to you why certain things make the first one easy, the second one a medium one, and the last one tough. We're actually going to do this by showing, first of all, how we get to this going backwards. So hopefully you understand that factoring is just undoing some sort of a distributive property. In this case, we're actually going to be undoing the FOIL method. So in our first example, when we do the easy problem, we're going to actually show how we get to this by foiling it, and then explain, hopefully, the backwards thought process on how we get back to and how we get back to a factored form. So let's go ahead and jump into the easy one first. Okay, for our first factoring problem, we're going to do x squared minus 2x minus 15. And again, the idea is we want to reverse the FOIL process. Well, here's what we're going to do. We know that the x squared minus 2x minus 15 is what we're supposed to get. I'm actually going to show this to you from the reverse perspective. Some of you may already be able to factor this, and if you can, that's great. I'm going to go ahead and show you what the factored form of this is. So the factored form of this is going to be x minus 5 and x plus 3. And if you're not sure how I did that, well, this is where I'm going to explain it. This is the factored form, x minus 5x plus 3. In order to get from the factored form back to what I have written in blue, we would basically have to FOIL this. Now, if you've never heard that term before, then this is probably going to be the first time you've seen this. But FOIL indicates, here, let me write this down. FOIL indicates basically just which components you're going to multiply together. It's just it's an acronym that tells you you're going to distribute each piece from one parentheses to each piece of the other parentheses by multiplication, and then we'll combine like terms. So the FOIL part, the F, stands for first. And that means you're going to multiply the first component in each parentheses. Well, if I multiply x times x, of course we get x squared. That's the F. Then the outside, outer in this case, means the outside pieces. So this is an outside piece, that's an outside piece, because it's the furthest away from each other. It's the two outside pieces. That's really what the O stands for in FOIL. So multiply the two outermost pieces together. So the white parts are going to give us x times 3, which of course is 3x. Inside means you're going to multiply the two innermost pieces together, which in this case, is going to be, let's do this here, the x and the negative 5. So of course x times negative 5 is negative 5x. And then the last, just like we did with the first where I underlined that in yellow, I'm going to underline these in, let's go with blue. Last is the last component, which is the negative 5 and the 3. Now some people like to draw like little lines and arrows and stuff like that, and that's fine, you can do that. If I multiply negative 5 times 3, we get negative 15. So now when you combine like terms, the first term cannot be combined with anything. The middle two terms here can be, and the last term is constant, it cannot be. So ultimately what you get is the first term, which is x squared. Combining 3x and negative 5x, we get negative 2x, and then minus 15, which is exactly what I started with in the initial problem. So the reason it's important that I walk through that is because when you undo this process, I'd use reverse FOIL. I know that this term right here, this first term, this thing, comes from multiplying the first two components together. It has to be the first two components. So again, I'm going to walk through it backwards here. My thought process is the first two components form this piece right here, the x squared. Well, the only two things you can do to multiply times x, to get x squared is to multiply x times x. So we're going to have x and x. Okay? The last component right here has to be what goes right there. The multiplication of two numbers has to give me negative 15. So in this case, there's really only a couple of possibilities. There's 1 and 15, 3 and 5. One has to be positive, one has to be negative, depending on which order you do it in. So if I tried 15 and 1, which of course is not right, but if I tried 15 and 1, or in any order, I know that if I was to double check my FOIL, x times x is x squared, but then the outside gives me 15x, the inside gives me 1x. I can't add or subtract 15 and 1 to get back to this 2x right here that I needed from the middle. So I know that's the wrong combination. So let's go ahead and change those to 3 and 5, because it's the only other multiplication factors that we can have. So 3 and 5, and it doesn't matter which order I put those in. What does matter, however, is the sign. This piece right here is a negative 2x, which means that I have to add these two numbers together, the 5x and the 3x, and get negative 2x. The only way to do that is if the 5 part is negative and the 3 part is positive. Now when you double check this with FOIL, first times first is x squared. Outside is 3x, inside is negative 5x. When I add those together, I get my negative 2x. And then when I multiply the last times the last, negative 5 times 3 is negative 15. So that's kind of how I walk through, and that's my thought process for factoring. I am reversing the FOIL process. Let's move on to the medium one. Okay, so in our medium problem to factor, we've got 3x squared minus 22x plus 7. What makes this a medium problem is the fact that the first number here is a 3. It's not just x squared, so we have something more to deal with. We have a coefficient, and that means that when we go ahead and factor this, the order that we put these numbers in is going to be important. But it's exactly the same idea. So here's the idea. Let's create our double parentheses. Again, reversing the FOIL process, I know that to get that 3x squared in the first place, that comes from the first component here and the first component here being multiplied together. Well, you have to have an x and an x in each one of them. And the factors of 3, which is pretty easy, it's just 1 and 3. There are no other factors. So I can put a 1x and a 3x. Now you don't really have to write the 1, but you can write that there if it helps you for the factoring purposes. Okay, so that part's done. There's no other combination there. I can't do anything else. The 7, once again, fortunately 7 is a nice one here, and the fact that it only has 2 factors. 1 and 7 are the only factors of 7. So the placement of the 1 and 7 is the important part here, though. If I place the 1 here and the 7 here, and I double check my FOIL, this is how I'm going to double check to see if I've got the right combination. If I do the outside and the inside, because I know that the first and the last are going to be fine. If I check the outside, that gives me a 7x when I multiply it. If I check the inside, that gives me a 3x when I multiply it. But I can't take the 3x and the 7x like we did in that FOIL process and combine those, because the O and the I have to add together to give me this middle number, negative 22. There's no way I can take 7 and 3 and add those together and get 22. That tells me that my order is wrong, which just means that I have to go ahead and switch that. So we're going to go ahead and switch it and put the 7 here and the 1 there instead. Now once again, the F part, no problem. First times first is 3x squared. We're good there. The L part, which is the last, 7 times 1 is 7. We're good there. It's the middle two, the O and the I, that I have to double check. Well, the O is a 1x. The I, multiplying these inner two pieces, is 21x. Well, can I add or subtract 21 and 1 to get to 22? Of course I can. I can add 21 and 1 and get to 22. So I have the right combination. The biggest thing I have to watch for is the sign. Now, the fact that I have 7 times 1 is going to give me a positive 7. But you could also multiply negative 7 times negative 1 to get a positive 7. And again, because this inside piece right here is negative, that means that the two numbers that I add together have to be negatives, which means that these have to be minuses. And again, you can just go ahead and double check. Now obviously you're not going to leave all these marks all over your page, but you could double check to make sure this is correct. So first times first is 3x squared. Outside is negative 1x. Inside is negative 21x, negative 1 and negative 21 add to negative 22x, so that's good. And then last times last, which is negative 7 times negative 1, multiplies to give me 7. So this is the correct combination. So if I was to rewrite it, it would just be x minus 7, 3x minus 1. That would be the factored form. And what made this more challenging was just the fact that we had that 3 out in front of the x squared. So the order that we placed these things did make a difference in this case. All right, let's finish off with the more tough one. All right, now we have the tough one. We're going to try and factor 12x squared minus 23x minus 24. So as you can see, we have a coefficient in front of the x squared, and that, of course, makes it at least a medium problem. What makes this tough is the 12 here has a bunch of different factors. The 24 here has a bunch of different factors, and this is really where you need to be good at your multiplication, doing some mental multiplication and some mental addition and subtraction. This is going to make things easier, and it is a little bit of trial and error. So when I go to factor this one, you set up your double parentheses the same way. I know I have to have an x and an x. The problem is 12 could be 1 times 12, 2 times 6, and 3 times 4. All of those are possibilities for 12. 24, it's even worse, is 1 times 24, 2 times 12, 3 times 8, 4 times 6. So I've got even more possibilities for 24. Our job is to come up with the right one. And again, it's a little bit of trial and error. There are other ways to do this where there's like a chart and everything. This is not the method I am showing here, but if you use that, by all means, go ahead and do it as long as it works for you. So ultimately, we're trying to find some kind of a combination. I'm going to eliminate the 1 in the 12 and the 1 in the 24 just for now. It could be that those are correct, but more than likely those are not going to add up to that middle one. That's just having a little bit of number sense, knowing that more than likely some combination of 12 and 24 is probably not going to get me to 23. Let's try maybe the 2 and the 6, and let's just see if this works. So I'm going to try 2 and 6. 2x and 6x. That comes from the first times the first, right there. So I don't know if this is right yet. We're going to check it out. If I was going to use some combination over here, I could use the 2 and the 12, the 3 and the 8, the 4 and the 6. If I try the 2 and the 12, maybe I'll put the 2 here and the 12 there. So on the outside, I would get 2 times 12, which is 24. On the inside, I would get 2 times 6, which is 12. I can't add 12 and 24 and get to 23, so that's not the right combination, but I got to try and switch the order to see. So maybe I would do the 12 here, oops, and the 2 here. But you should be able to tell pretty quickly 12 times 6 is a pretty big number, and I'm not going to be able to add or subtract that with the 4 from the outside and get there. Another thing you could look for here is the fact that when I put the 2 and the 12 in there, I have a 2x and a 12x in the first one, and a 6x and a 2. Everything is divisible by 2, so something would not be right there because I would still have a way to factor a greatest common factor out of there. Okay, so let's go ahead and try a different combination. Let's try the 3 and the 8. Well, once again, the 3 and the 8 is probably not going to be correct, and I'll show you why. If I put the 3 here and the 8 here. Okay, so the outside gives you 16, the inside gives you 18. 16 and 18 can't add to 23. But again, the biggest thing is I see that the 6 and the 8 here had something in common. They have a 2 in common, which tells me this wasn't going to be the right combination because I had no, up in the top, I had no common factors that I could pull out of that whole thing. And then if I were to switch the order and put the 8 where I'm erasing the 3, then that would have given me a 2 and an 8 in the same place, and that won't work. So we're going to eliminate the 3 and the 8 from this one. Again, the 4 and the 6, before I even plug this in, the 4 and the 6, if I plug a 4 and a 6 into either one of those two parentheses, everything is even, so it all could be divided by 2. Most likely that's telling me, and you could definitely try it, trial and error, that this is not going to be the right combination. This 2 and this 6 over here didn't work. So, unfortunately, I did not try the right one first. So let's go ahead and cross that out. That wasn't it. So let's try the 3 and the 4. Okay, this has got to work because otherwise it's not going to be a good problem here. So let's go back. The 1 and the 24 aren't going to work because, once again, the 24 here has something in common with the 3 and the 4. So that means I would have missed something. I could have pulled something else out. The 2 and the 12 are not going to work because, once again, if I put a 2 in one of these, just for example, if I put a 2 here and a 12 here, in the first parentheses I could have pulled out an extra 3. In the second parentheses I could have pulled out an extra 2. That's not going to work. That's not right. Okay? The 3 and the 8. Well, that might work. So let's try the 3 and the 8. If I were to put the 3 here and the 8 here, at least you can see now that each set of parentheses is not going to have something in common. The first parentheses I have nothing in common. The second parentheses I have nothing in common. So let's see if this works. If I do first times first, I get my 12x squared. Last times last, we get the 24. So the outside would give me a 9x. The inside would give me a 32x. Can I take 9 and 32 and either add or subtract 9 and 32 and get to 23? Well, 9 plus 32 is 41, so that's not it. But how about 32 minus 9? Well, that is 23. But of course, I want that 23 to be negative, so really, instead of 32 minus 9, I wanted it to be negative 32 plus 9. That would give me negative 23. So that means that my negative 32, that means that the combination right here, this one, has to be my negative. So that means the minus sign goes with the 8. And the 9, which is the outside one, has to be positive. Oops, don't want an extra piece in there. There we go. So there is your factor. It should be 3x minus 8, 4x plus 3. Okay, that is definitely on the more difficult side because of so many factors that this thing had. But ultimately, it is exactly the same process, and that's kind of how I would go through factoring.